All right, so now on to Hess's law, number 11. I'm not going to write them all out, but I will just tell you exactly um, what I'm doing and why. So 11, we are trying to get that overall reaction to be plus 3H2 goes to B2H6. We did do this one, I believe, in the lecture. So you're going to need to flip the second equation, the second step, and that gets you your B2H6 on the right side. So when we flip that, our delta H value will also be flipped to 2035 kilojoules. And then we're also going to leave number 1 as is because that gets us our 2 boron atoms on the left. And so delta H for that stays as negative 1273 kilojoules. And then you're going to have to take number 3 and multiply by 3. And that will help get the 3H2 molecules that you need on the left. And our delta H for that will end up being negative 858 kilojoules. And then number 4, you're just using as a way to cancel some things out. I was looking at the waters, using this to cancel out those 3 H2O liquids on the left and the 3 H2O gas on the sorry, the liquids on the right, the gases on the left. So we're going to have to take number 4 and multiply it by 3 so everything cancels out. And our delta H for that would be positive 132 kilojoules. You add them all up for a delta H of the reaction as 36 kilojoules. That's your final answer for that. Now, number 12 is a bit trickier because you're going to actually be asked to solve for the delta H of one of the steps rather than the overall process. And so what I would do, what I did for this one is just, you're going to do the same setup. You're going to try to manipulate those steps in order for them all to combine to that overall equation. So what I did was I noticed that you're going to have to take number 1 and divide it by 2 to get that 1/2 N2. When you do that, our delta H will also be halved to negative 46 kilojoules. We're going to take our number 2 step and we're going to have to use that in order to get the 1 NO molecule on the right. So we're going to have to divide it by 4 because that reaction has 4 of them and we only need 1. So delta H will also divide by 4. And so negative 906 divided by 4, we get negative 226.5 kilojoules. And then lastly, we look at number 3, and we're going to use that basically just to cancel a bunch of stuff out. And so what I did is I flipped it. You're going to flip number 3. And then here's the tricky part. You're actually going to have to multiply it by 3 and then divide it by 2 in order for everything to cancel out. So I would suggest doing that. It's a little bit of fraction multiplication, but I would do that and write it all out just so you can actually see it. And then we're solving for this delta H value. We want the delta H for the original step. So we're going to actually, and I'll just call it delta H3. And so we're going to have to do the same manipulations that we did to this to the delta H value. So flipping it will mean that we'll have to put a negative sign out front. and then we're going to have to multiply it by 3/2. Okay, so all of this added up, we'll take the first step plus the second step plus this third step, and it's going to all have to equal 91 kilojoules. So I'm going to do that on the next page. So we have -46 minus 226.5 minus, I'm just going to bring the 3 halves out front and put delta H3 there. And that's going to be equal to 90. All for delta H for step 3. By first, I would move these guys over to the other side, and they're going to have to multiply by the reciprocal here, which will just be -2/3. And so what you should get is -242.3 kilojoules. And that's the delta H for the original third step as it was written in the problem. All right, that's it.